Hello and welcome to Chapter 2, Lesson 7, Flowchart and Paragraph Proofs. You will notice that this is Lesson 7 of Chapter 2. We have skipped over Lesson 6 for the time being. We will come back to that, but there are certain parts of the lesson that I will be eliminating from the notes until we can go back and look at Lesson 6. So just make sure you're paying attention and following along with the correct example each time. If at any point you feel like you are not in the right place, pause the video until you can find your correct place in the note packet. We're going to skip over the warm-up for now and take a look at our objectives and jump right into the lesson. Today you will be writing flowchart and paragraph proofs, and you will be proving geometric theorems by using deductive reasoning. Flowchart and paragraph proofs are types of geometric proofs. We've talked about algebraic proofs in Lesson 5. Lesson 6 talks some more about two-column proofs that we're going to look at a little bit today. But then the other two forms, flowchart and paragraph proofs, are going to really help us understand proofs a little bit better. So let's take a look. A second style of proof is a flowchart proof. The definition you need to write down is flowchart proof uses boxes and arrows to show that the structure of a proof. Again, uses boxes and arrows to show the structure of a proof. The justification for each step is written below the box. That means the reason for each statement in the flowchart proof is written below the box containing that statement. One of the theorems we will be discussing in this chapter is the common segments theorem. It states, given collinear points A, B, C, and D arranged as shown, if AB is congruent to CD, then AC is congruent to BD. What that says, in a segment arranged like this, if segment AB and segment CD are congruent, we have this common segment BC that allows AC to be congruent to BD. And we'll look at a proof of this statement later on in class. So let's go ahead and take a look at example 1. Use the given flowchart proof to write a two-column proof. This flowchart proof uses the given information. Angle 2 and angle 3 are complementary. Angle 2 and angle 3 form a right angle, so you can see that they are complementary. And we are told angle 1 is congruent to angle 3, so 1 and 3 have the same measure. We are to prove that 1 and 2 are complementary, or rather 2 and 1, but the order is not important. So they give you the entire flowchart proof. This proof tells you why we can say 1 and 2 are congruent, complementary rather, based on the given information. So let's take a look at how this is organized. You're told angle 2 and angle 3 are complementary. That's given. The other given represents a different branch. These are not necessarily related, so they separate the givens in two different branches of the flowchart proof. Starting with the first given, that tells you something else. The measure of angle 2 plus the measure of angle 3 equals 90 degrees by definition of complementary angles. Then before we can say this next step, you have to examine the other branch. 1 and 3 are congruent angles, that's given. So their measures are equal by definition of congruent angles. We have to talk about them having equal measures because this statement uses measures of the angles rather than just the figures themselves. We've gone from talking about congruence to now talking about equality. Since 1 and 3 have equal measures and 2 and 3 add up to 90, I can substitute the measure of angle 1 in place of the measure of angle 3 and get this equation. And if this is true, 2 and 1 are also complementary by definition of complementary angles. We're going to take all that information and put it in the traditional two-column format like this. We start with our given information. That goes up there in the first place of your two-column proof. But there is more than one given, so this time we're going to include the givens in the same line. And there's for the same reason, so you don't have to write given twice, you just include it all in the same reason. Now we can go back to talking about this first statement branching off of the first given. That would be our next statement in the proof. That one goes there. The reason goes on the right. Then we can go back up here and talk about what this other given statement tells us. If they're congruent, then they have equal measures. So that goes in the appropriate place there with the given reason. And then we can put these two thoughts together and come up with statement 4, putting the reason on the right. And lastly, we take the final step, we put it in for statement 5 with the reason on the right. So to clarify, it looks a little bit more like this whenever you make it all nice and neat. So why don't you take just a moment and take this flowchart proof and put it into a two-column format. It would help if you start numbering each of these statements in the order you think they go. This is your given. In this situation, RS equals UV, ST equals TU from this given diagram. You are to prove that RT is congruent to TV. So this is the flowchart proof. First you state the one given piece of information. There's actually two, but they're grouped together. That tells you this. And then, before we can say this, you have to say this. So this kind of helps you see the order these should follow. And then we end our proof with this. So there will be 1, 2, 3, 4, 5 statements along with their corresponding reasons that go in a two-column proof. Take just a few moments, try and put that in a two-column proof. Alright, if you didn't have quite enough time, go ahead and pause the video to give yourself some more time, but as soon as you're ready, click play, and you will see that our answer for a two-column proof for this paragraph proof should look something like this. Your first box goes here because it is given to you. That tells you this statement by the addition property of equality. We take RS equals UV and we add ST to one side and add TU to the other, but those are equal values, so we're really adding the same value to each side, so we get that. But we also have the segment addition postulate that we have to use before we can substitute anything. But once we've substituted, we have a final statement based on the definition of congruent segments. In example 2, we're going to take a look at using a two-column proof and writing that as a flowchart proof. And it's a little bit more simple to do in this way because we just have to take apart these pieces and organize them almost like a puzzle using the correct direction for our arrows. So here's what we have. We are given that B is the midpoint of AC. We could mark that with the tick marks to show that AB is congruent to BC. You'll see that is definition of a midpoint. That tells you the second statement. And in order to prove that 2 times this length equals AC, we're going to go through the proof like this. AB equals BC by definition of congruent segments. Then, if I add AB plus BC equals AC, according to the segment addition postulate, step 4 here, I know that not because these three are true, but because just of the given diagram. So this is going to be a separate branch of your flowchart. But once you know this, then we can take these values and substitute to get this equation, taking out BC and replacing it with AB. And then we just have to simplify this equation to get this. So that's the proof. We're going to step through this and place this in to a flowchart to make it easier to understand. So here are the separate pieces, the 6 statements with their corresponding reasons. They're just written up here in their boxes. We're going to organize these together. Don't feel like you have to write all this down until we get to our final result. But we're starting with the given information. We always start with the given first. B is the midpoint of segment AC. So we're going to start with that. And then that tells me this next part. These are related because both of these are talking about the midpoint. Because B is the midpoint, by definition, I know this. AB is congruent to BC. So this statement comes directly after this statement. I'm going to draw an arrow to show that connection. This statement directs me to that statement. Because this is true, by definition of congruent segments, AB equals BC. So I can take that segment and write it next. Again, writing the arrow, or drawing the arrow to show that this leads to this, and that leads to that. But before I can say anything else, this statement, AB plus BC equals AC, comes from our segment addition postulate. Like I said earlier, that is a separate branch that is going to lead me to another statement. And so I'm not going to connect it to anything else yet. It's going to lead me to this statement right here. Because of the segment addition postulate, then I have an equation I can substitute equal values into. So that is where I come up with this statement. Now I need to show that this statement and this statement give me this statement. So finally, we can finish our proof with this statement. And again, you'll need to draw your arrow linking the previous statements to this one. So once again, our results should look like this. This is our first statement. That leads you to this one, which leads you to this one. But before we can talk about anything else, we have to have stated the segment addition postulate. These two tell us this. And lastly, we can conclude our proof this way. So your flowchart should look something like that. Okay, you'll notice that we skipped over part B in that example. We're going to jump straight into paragraph proofs. A paragraph proof is a style of proof that presents the steps of a proof and their matching reasons as sentences in a paragraph. Although this style of proof is less formal than a two-column proof, you still must include every step. We will cover these theorems either in the following proofs or later on in class, but we do know that vertical angles are always going to be congruent, so we have the vertical angles theorem that states that. And we know that if we have two congruent angles that are also supplementary, each angle must be a right angle. In example 3, you're going to use the given information and the paragraph proof to write a two-column proof. We are given the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. We need to prove that the measures of angles 3, 1, and 2 all add up to 180 degrees. It's given the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. Notice that first statement just covers the given information. The next sentence will talk about what we know now. Angle 3 and angle 4 are supplementary by the linear pair theorem. So the measure of angle 3 plus the measure of angle 4 equals 180 degrees by definition. Then by substitution, the measure of angle 3 plus the measure of angle 1 plus the measure of angle 2 equals 180 degrees. In order to write this as a two-column proof, we're just going to take it one sentence at a time. First, we'll state the first sentence, and the reason is given. We just don't have to put it in sentence form. Then we're going to take the next idea, 3 and 4 are supplementary, and write the reason. And then we'll take the next sentence, writing that statement. And if it says by definition, you will say definition of whatever you're defining. Supplementary angles is what we just referred to. And then lastly, we can substitute to get this equation, which is what we were supposed to prove. In example 4, we're going to take a two-column proof and translate it back to a paragraph proof. And it can be done very simply. All you have to do is read these and put them in sentences. So 1 and 2 are complementary. That's given. 1 plus 2 must equal 90 degrees by definition. We also know that 1 and 3 are congruent and 2 and 4 are congruent by that vertical angles theorem. So their measures must be equal by definition. And by substitution, we can say 3 plus 4 must also be 90 degrees, so we know 3 and 4 are also complementary by definition. So we could put that in a paragraph like this. Angle 1 and angle 2 are complementary, so the measure of angle 1 plus the measure of angle 2 equals 90 degrees by the definition of complementary angles. Angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4 by the vertical angle theorem. So the measure of angle 1 equals the measure of angle 3, and the measure of angle 2 equals the measure of angle 4 by the definition of congruent angles. By substitution, the measure of angle 3 plus the measure of angle 4 equals 90 degrees. So angle 3 and angle 4 are complementary by the definition of complementary angles. Once again, all the information is given to you. We just have to be able to write it in sentence form. Why don't you take a moment to read through these statements and reasons and write your own paragraph proof. Okay, hopefully you've had a chance to write those sentences. Let's take a look at what we end up with. It is given that angle 1 and angle 4 are congruent by the vertical angles theorem. By the vertical angles theorem, angle 1 and angle 2 are congruent, and angle 3 and angle 4 are congruent. By the transitive property of congruence, angle 2 is congruent to angle 4, and in a similar way, angle 2 would be congruent to angle 3. So, hopefully you've had a chance to understand these a little bit better. Feel free to ask any questions in class. Some of the examples that were skipped over in this video for the sake of time will be talked about in class. So, go ahead and take a look at the assignment if you would like to, and come ready to talk about paragraph and flowchart proofs.